Welcome to AI's next leap: trust, transparency, and teamwork. In this episode of AI Frontiers, we review 28 cutting-edge papers in computer science, artificial intelligence, focusing on advances in trust, reasoning, and teamwork. Key breakthroughs span disciplines such as science and finance. Today's spotlight is on the modular speaker architecture, as we explore the evolving city of AI innovation together. Imagine stepping into a hospital in 2030, where your diagnosis is generated by an AI system whose reasoning and uncertainties are fully transparent for your review. This future, in which every hunch and hesitation is clearly marked and expert consultations are seamlessly integrated, is rapidly becoming a reality thanks to today's research. Would you trust such AI decisions? The work discussed in this episode is laying the foundation for transparent, trustworthy AI in critical settings. Artificial intelligence now designs medicines, predicts financial crimes, and addresses complex challenges across industries. In this episode, 28 recent papers are examined to chart the rapid evolution of computer science, artificial intelligence, or cs.AI. We will explore significant advances, overarching themes, and emerging future directions, demystifying not only what AI does, but how and why it is changing. Join us for in-depth insights, engaging stories, and a clear view of AI's real-world impact. Computer science. Artificial intelligence, often called cs.AI, serves as the brain behind digital assistants, robots, and automated systems. Imagine cs.AI as a dynamic city with neighborhoods dedicated to language, vision, and decision-making systems, all interconnected by the algorithms and data that drive progress. This city is in continuous expansion, opening new roads and renovating districts, fundamentally transforming science, business, and daily life. The first major theme is enhanced reasoning and language models. Today's models solve complex, multi-step problems across domains. The ChemAU framework, introduced by Zhang and colleagues, flags uncertainty at each step of reasoning, much like a detective double-checking evidence. This approach enables safer scientific discovery by incorporating uncertainty estimation, allowing the AI to identify what it does not know, and making it both smarter and more reliable. The second theme centers on digital teams and accountability within multi-agent systems. The Modular Speaker Architecture, developed by TOE and collaborators, tracks roles and responsibilities among AI agents, coordinating them like a well-coached sports team. Robust communication protocols prevent confusion, and alignment mechanisms ensure agents stay on mission. Think of it as AI referees maintaining fairness and clarity in the digital game. Theme 3 addresses AI safety, robustness, and trust. Automated red teaming, as described by Lee and colleagues, rigorously tests AI defenses. Explainability frameworks, such as those developed by Patel et al., trace the origins of decisions, resembling the process of following a recipe back to its original ingredients. These advances are critical for building trust in high-stakes environments, with red teaming serving as a vital method for stress-testing AI vulnerabilities. Several key findings illustrate the field's progress and surprises. The ChemAU system flags uncertainty and invites expert corrections, improving transparency in scientific discovery. MCP-0, introduced by Shen et al., assembles toolkits on demand, significantly reducing resource consumption. The conformal arbitrage framework by Kim and colleagues balances helpfulness and safety in AI systems. Medbook VQA, from Singh et al., provides multimodal benchmarks that reveal current AI blind spots. These advances highlight that true progress in AI is measured by trust and reliability, not just intelligence. The modular speaker architecture, developed by TOE and colleagues, addresses the challenges of multi-agent communication. This framework ensures that each AI agent is aware of its role and duties, preventing the phenomenon of lost responsibility in complex conversations. By tracking context and maintaining coherent dialogue, the system draws inspiration from effective human team dynamics, supporting robust coordination in digital environments. Inside the modular speaker architecture, several components work in concert. The speaker role module assigns digital name tags and task descriptions to each agent. The responsibility chain tracker ensures that commitments are passed cleanly and transparently. The contextual integrity validator flags any inconsistencies in conversation. The framework features a prototype configuration language and a user-friendly API, and has been evaluated using annotated case studies and novel structural metrics. The impact of the modular speaker architecture is significant for AI teams. It consistently outperforms previous systems in maintaining pragmatic consistency and keeps digital teams aligned, even as roles and contexts shift. Its adaptable design supports applications in negotiation and conflict resolution, enabling trustworthy collaborative AI in real-world tasks. This framework paves the way for interpretable, responsible teamwork among artificial intelligence agents. Looking ahead, AI research resembles a river, with each new framework and discovery adding to its strength. Deeper integration of domain knowledge and uncertainty tracking is making AI more trustworthy across science, healthcare, and industry. Scalability is being reimagined, with agents adapting workflows much like a creative chef selects the best ingredients per task. New benchmarks are guiding improvements in fairness, safety, and effectiveness, while responsibility frameworks prepare AI for seamless human collaboration. To recap, AI is rapidly evolving toward greater transparency, accountability, and safety. Advances in reasoning, teamwork, and explainability, as seen in the works of Zhang, To, and Patel, are driving these changes. The next major breakthrough may arise from any direction: algorithmic innovation, novel datasets, or communication frameworks. Listeners are encouraged to explore, share, and experiment with new AI ideas, and to actively join the journey into the ever-expanding city of artificial intelligence. This synthesis was created using advanced AI tools and human expertise. Summaries were generated via GPT 4.1 from OpenAI, TTS audio was produced with DeepGram, and supporting images were created using Grok. Each segment has undergone human expert review to ensure clarity and accuracy, though some oversights may remain. All references are provided for transparency, which is the guiding principle of this work. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.